It's going to be simple when you explain it, but I just want to make sure.
All right, so question 5, we're looking at the angles of a pentagon. Okay, so a pentagon is a 5-sided shape. So it's 1, 2, 3, 4, something like that. Okay. But it's supposed to be a regular pentagon, so it's supposed to all be nice, the same size, whatever. Oh no, it's not necessarily. No, not necessarily. And they're just giving us the angles. They've said this angle here is y. They've said one of the angles is y plus 10. So I'm going to say this one here is y plus 10. They've said another angle is y plus 20. So we'll just say that one is, so it's definitely not a regular pentagon. This is like a weird pentagon. So mine probably looks pretty accurate. Y plus 30, y plus 40. And they want to know what is the size of y. Now, in a pentagon, I know this. There's two ways to find the formula that's total sum of all the angles. The one is to do the n minus 2 times 180 degrees. That'll give me the sum of all the inside angles, where the n is the number of sides. In other words, 5 minus 2 times 180. I prefer the other method, which is if you look at your exterior angles, you know that your exterior angles all add up to 360. So the other method is to say 360 divided by 5, and that'll give me on average the size of the interior angles. And then actually no, I'm not going to use that one now. I'm going to use the other one, because this would actually give me just one angle if it was a regular pentagon. This is not a regular pentagon. Sorry, that method only works with regular pentagons. So I'm going to use this method. I know there's 5 sides, so the n is the sides, right?
Yeah.
So if there's 5 sides, I'm going to say 5 minus 2 times 180, which is quite an easy one. It's just 3 times 180. How's your 180 times table, Sarah?
Hold on. Good. 500 and... Oh no!
You got it. I just got it at the same time as you. That's why we were just working together. All right. All right. So we know that it's 540. That's the total sum of all of those together. So now let's add them all up, because that has to equal. So my 540 has to equal y plus 10 plus y plus 20 plus y plus 30. Why is this whiteboard so small? Plus, let's close it, y plus 40. So in other words, my 540 has to equal what? It has to equal, well, let's add up all the y's. 1, 2, 3, 4, 5 y's. Let's just add all my y's together. And then we're going to add the numbers, the 20, the 10, the 30, the 40. So 10 plus 20 is 30, 30 plus 30 is 60, 60 plus 40 is 100. Happy with that so far?
Yeah.
Then I want the y by itself. So what am I going to do? I'm going to then subtract 100 from this side, get the hundreds away, but whatever I do on the one side, I has to do on the other side. So I subtract 100 from both sides, and I get that 440. I'm going to just switch it around. I'm just going to say the 5 on the side. It just looks neater. Equals 440 degrees. Okay, because that's the 540 minus 100. I now need to get the y by itself. So 5 times something must be 440. So in other words, to find the y, I can just divide both sides by y. I mean by 5, not by y. Don't divide by y. Divide by 5 rather. And you got your calculator there?
Yeah.
What's 440 divided by 5?
40 divided by 5 is 8.
That's y. Y is 88.
Okay, that's not that bad.
That's not that bad.
Well, is that all? Wait, where does is y.
Then they say work out the largest angle. So this was just A, right?
Yeah.
So go back. We know y is 88, right? Go back to your shape. Which of those angles is the biggest?
40.
The y plus 40. Good. So for B, you're just going to go 88 degrees. Oh, where did my pen go? My pen's doing weird stuff. Plus 40 degrees. So what's 88 plus 40?
168. 148.
No, what do you do? No, use your calculator.
I'm trying to learn how to use my 120.
There we go. Okay, you're
I
no.
didn't use my calculator. I figured it out last.
Good. So you did it without your calculator. Well done, you. What do they want us to do? Is that it? Oh, that's it. Then it's number 6. All right,
I
now,
didn't see that when I connected that. Yeah.
now you're going to help me with 6. Okay.
Okay.
Because now your teacher's just forgotten how to do all of this. I can't remember any of it. So they say in number 6, a hexagon has 6 sides. Okay. I'm going to put that there so long. N equals 6. We'll put that there because we know that n is the number of sides. Draw a hexagon.
Okay.
How would we draw that?
Draw a line draw like a triangle line.
Yeah?
Draw another one.
Yeah?
1, 2, 3, 4, 5. And then connect those.
Does that look alright?
1, 2, 3, 4, 5. Maybe make it bigger.
I don't know if I can. Let's see.
There you go.
Oh, there we go. Isn't that a beautiful hexagon? Huh? I'm
Yeah.
not sure what went on in that side. That side, someone's been sitting on it. Got a little bit squashed. Anyway. Alright, so that's A. A was easy enough, huh?
Yes.
Then they say, now obviously if you did get a test, you'd use a ruler. Then it wouldn't look like mine. By joining the vertices, split it into triangles. What do they mean by joining the vertices? Well, what they want you to do is they want you
Angles
to...
across from each other? I don't know.
Yes, well, kind of across from each other. So they want you to take the one vertex.
No, I know. You don't have to explain.
Do you know what to do?
Okay. Yes, and then, oh no, I was going to do it the other way. I was going to connect the first line and line the other one.
That's good enough. Because I can't connect anything else. That's what they want you to do. It's difficult to...
Okay. So there's 4 triangles.
There is 4 triangles. Good.
By joining.
And they say by joining the vertices, split into triangles, and then they say using that now. So that was B. Now using B, they're saying now use what you've just done to show that the sum of the angles, so that the sum of the angles equals 720. That's what they want us to do. So how many triangles have we got?
4.
Right. What are the angles of a triangle add up to?
180.
Good. Of a triangle equal 180. So we've got 4 triangles. 4 triangles equals 4 times 180. Happy with that?
Really sure.
And this is C that I'm doing now. This is little c.
Okay.
So
How big is each angle of a regular hexagon?
hold on, we're not there yet.
Oh,
What is 4 times 180?
4 times 180. 720.
Right, now we've done C, now 2 minutes. So now they said D, if this was a regular hexagon, in other words, all the sides were the same length, if someone hadn't sat on it earlier, then what would each angle be? So each angle is the same size, right? And we've got how many angles?
6.
6 angles. And if they add up to 720, how are we going to find out how big one is?
6 divided by 700. I don't know.
Or other way around.
720 divided by 6, other way around.
Yes, that way around. Okay, tap that out of your calculator. 120 is correct.
Yay!
Was that hard?
No, it's just, I think, like, when I do it on my own, it actually seems harder. So, yeah.
All
I
right,
didn't get further than that, so.
try number 7.
Where's it? Oh, there. Calculate the missing angle of this hexagon. So the angle is that. Where's my pencil? Go. Okay. Oh, what is, okay, what is that? Do I have to add them all?
Yes, that's the first thing you're going to do. Add them all.
130 to 11. 8. 1, 3, 6. 1, 2, 5. 611.
You got 611. So when you added them up, they came to 611.
Yes.
But how much should the angles of a hexagon add up to?
But I split it into triangles.
You could, but we just did that in question 5, in question 6.
Yeah.
So,
Okay.
so what did we get?
I don't remember. Oh my gosh.
Shall I go back? Does that look
Did it
familiar?
have, oh, is that what it actually, okay, I thought that was just a random number, okay.
So every single hexagon, it doesn't matter what the hexagon looks like, every single hexagon, because you're going to use that number of, because you see when you break it up into triangles, you're always going to get 2 less triangles than there are sides. So if it's a hexagon, it'll have 4 triangles, and 4 times 180 is 720. So it doesn't matter whether it's a regular hexagon or this weird looking hexagon they've given you, it'll always add up to 720 because you'll always be able to break it into 4 triangles.
Okay,
So
it is 109, that is the thing.
109. Sarah,
Yes.
that is correct.
Yay!
Now what are you going to do for B? Because it's still a hexagon. Can you see it's still got 6 sides?
Yeah. Cool. Let me see. B. Calculate the value of x.
Mm-hmm.
That's first of all,
Mm-hmm.
105 plus 130. Okay.
Okay, what was your total?
430.
430. No, not 430. I know what you haven't done. You haven't gone and added the little angle that they've given you that looks like that.
Oh yeah, I didn't add that.
How much is that?
Okay, that's a right angle, so that's
Yes, good. So don't forget your 90. They're being tricky, Sarah. They're trying to catch you out.
5 point.
Perfect. 520 is
Okay.
correct. Okay, and then what are you going to do next?
They're the same, the angles.
The angles will be the same, yes?
Okay, so what would it? It would have to be something that would. Okay, so I go 720 minus 500 is 20. 200 divided by 2, so that would be 100. Is that right?
Yes.
Okay, good.
Because you get the 200, yes, and then you divide it by 2 because there's 2 angles.
Yes.
So yes, it's 100 degrees.
Yay! Can give me something.
Look at you. Right. What happens, Sarah,
Yes.
when we're now not working with a hexagon anymore, which was nice and easy, it was 6 sides, we figured out the 6 sides add up to 720. We now want the sum of the angles of octagon. How many sides does an octagon have?
8.
Good, so our n is 8, right? Number of sides is 8. So how many triangles will there be?
Oh, 5.
Keep going.
Yep.
Good. There'll be 6 sides. Why? You'll always have 2 less than the number of sides. So how do you work out the sum of the angles? If there's
Dividing them into triangles.
Yes,
What is the
divide-
total of an octagon?
Well, an octagon has 8 sides. Right, hold on. Give me a minute. I'm
That's
gonna
the total.
find you an octagon, and I'll show you.
Thank you. Find me an octagon.
Yeah, I've got to find you an octagon. How could we not have an octagon in an octagon question? Right, that one looks good. I think I'm going to use that one. Print screen. No, print screen. There we go. Right, then let's cut that out. And let's go back into here. And I'm going to paste. Oh, don't do it like that. There it is. Okay. So that's an octagon, right? 8 sides. Can you see all the 8 sides? Now,
Yeah.
we're going to make triangles. 3 hookies. Triangle 1. So you just start at one corner and then you go to all the corners you can connect it to. You obviously can't connect it to the corner immediately next to it because that would just make a straight line. But we go to every corner that we can make a triangle from that one. And let's see if there are, we said 6, let's see if there are 6. Okay, there's your triangles. Count them for me.
1, 2, 3, 4, 5, 6.
Awesome, so 6 triangles. And each triangle is how many degrees?
180.
Good, so each triangle is 180 and we've got 6 of them, right?
Okay, hold on.
I'm holding on.
1,080. 1,080.
That's it. That would be the sum of all the angles of the inside of an octagon. Okay, you happy with that?
Done.
Okay, while you're copying that down, I'm going to go. Oh, do you want to divide that now by 8 to get each angle? Let's do that.
135.
Did you get 135?
Yes.
That's each angle then. So each one of these angles is 135 degrees. Cool, eh?
So what am I meant to do? I can't read what that says.
Oh no, you only meant to find that. That's all they wanted was the sum.
Oh.
So the 1180 answers that question. Now they're going to do a decagon.
Yes.
Sarah, how many sides does a decagon have?
20. I'm joking. It's 10.
It's 10. Do you think they'll give us a decagon? Let's have a look and see if I can find us a decagon. Decagon. Yay!
I think that's my new thing now.
I found one.
Yay!
Oh, that one's small, but doesn't matter. It'll work. I'll just enlarge it.
Just make it bigger.
I'll make it bigger. Why does my computer take so long to do the print screen thing? Right. Copied. Get the little pointy arrow. There we go. A decagon. Alright, so we know it's got 10 sides, right?
Yes.
Now, without my even having to draw the triangles, can you tell me how many triangles we'll have?
8.
Correct. Triangles will be 8.
Oh.
So how do I get the total sum of all the triangles?
180 times 8.
Perfect.
Do you know, Daryl, do you know the shape of the most sides in the entire world?
Yes, I do.
What is it?
A circle.
Oh, I was hoping you wouldn't know so I could tell you. Okay, what are we doing? 8 times 180. 1,440.
Well done, you. Did you do that in your head or on the
Divided by
calculator?
10 is 144.
Yes, so each angle on the inside would be 144 degrees.
Yay!
It's easy stuff, huh?
Yeah.
Good. Number 9, you can do number 9 when you've got time, because it's just, all it is writing the number of sides and the sum of the interior angles. So all they're doing with number 9, they've got this table. So it's a table, and they say, right, on the one side we've got the shapes. We're going to do a triangle. We're going to do a quadrilateral. We're going to do a pentagon and a hexagon and so on. And you've got to say the number of sides. How many sides do they have? So you know that's 3, you know that's 4, you know that's 5, and so on. Pent, hex. They miss out 7 and they miss out 9. They go from hexagon to octagon to decagon, which is fine. And then the sum of the interior angles of triangles. What I'm going to do is I'm just going to say always take 2 less than that, because it will always be the number of triangles will always be 2 less than the number of sides. So that would be your 1 times 180, but they've given you the next one, which would be 2 times 180, 3 times 180, and so on. And so it's just showing you that you multiply 180 by 2 less than the number of sides every time. And then that would be your 180, that would be your 360, that would be your 540, and so forth. And so it's just a case of just getting used to what the relationship is between the number of sides and what you multiply 180 by. That's all it is. And then they say to derive a formula. Now remember, we said the sides, we're going to use the letter N for the sides, right? So then A will just be completing the table. It's very easy. B, the formula, I'm going to give it to you. We've already seen it once today, is N minus 2 times 180 degrees, where N is your number of sides. Then for C, they ask you, well then, seeing as you're so clever, we want you to work out the sum of the angles of a nonagon. How many sides does a nonagon have?
9.
Good. So it's a nonagon. That's when your grand's left. Nonagon.
When my gran is left.
Yeah.
My
Nonagon.
granny.
Yeah, she's gone.
She's still here.
No, nonagon. Look, nonagon.
Oh, Nana. Okay.
Alrighty, now. If it has 9 sides, what do we multiply 180 by?
7.
Good. And that is
180 times 7. 120. 1,206.
There we go.
120.
Easy, huh?
Okay. And then divide it by 9.
Yes, if they want each individual angle, but they don't.
I know, but I'm just making sure every time.
Yeah, so then, yeah, you divide. Now look, Sarah, they got me yawning. You don't let her yawn. Don't you know yawns are contagious?
Yes, I know.
Yeah, so then you divide that by 9, and how much is each side then?
It's 140.
Good, 140 is correct. 140 degrees. That's it. This section is easy, isn't it? Now, Sarah, they are going to ask you some pretty tough stuff later.
Oh no.
Firstly, that was now Nice working with shapes. I wonder if I can just get... Ah, it's still there. Look there, it's still there. Good. I'm going to use this. This was what? This was our decagon, eh? Yeah. Okay. We're going to look at exterior angles now.
Exterior.
Exterior, the angle on the outside, the beta cant. So we want this angle over here. Now, the exterior angles of any polygon. So the exterior angles. Oh, why am I writing exterior? It's not exterior anymore, it's exterior. Exterior angles of any polygon. Polygon, you've lost your parrot. Polygon. Nanogon, now polygon. They say any polygon, sum, you know sum means add up to her.
No, I do.
Well, now you do. Sum means add up to. Okay. So the exterior angles of a polygon, where did the word any go? I'm forgetting to write words of any polygon sum to 360. It doesn't matter what the polygon is, the exterior angles will add up to 360. Now this is a regular decagon. So knowing that, I can go and I can work out what the exterior angle is.
Wait, so a polygon is 7, right?
No, a polygon is many sides. Polygon. This is a decagon. This is a deca.
Wait, what?
So this is when there was a big storm, you had a deck, and now you come out and it's gone. The decagon.
Okay.
All right. Now, there will be 10 exterior angles, won't there? Because there's 10 sides.
Yeah.
So all I do is I just say 360 degrees divided by 10. What does that give me?
36.
So the exterior angles of a decagon are all going to be 36 degrees. And that's all you do for any shape, is you work that out. Now, obviously this is only for regular shapes, because if I make it an irregular shape, then each exterior angle will be a different size to the others. What you'll also see, remember when we did decagons, you worked out that the interior angle was 144, right? Do you remember? Bloody idiot.
Who is shooting there?
It's a car backfiring. Just about gave me a heart attack.
Shame.
All the people in the street are screaming as well. I think we must find that idiot with that car and stick his head up his exhaust. Alrighty.
Yeah.
See, it's even got your dog barking now.
Yeah.
And you're not even here. It's
My
just...
mom's outside.
Oh, okay. Alright, now, Sarah, if you add 144 to 36, what do you get?
101. Okay, wait, let me do this without a calculator. Okay.
Yes.
Then 180.
Good. So can you see you can use this method, but this only works if it's a regular shape. So if you've got a regular shape, you can find the exterior angle simply by saying 360 divided by the number of sides, and then subtract that from 180. That will give you the interior angle. Now, knowing that, there's a question in your exercise that does this. They take a shape and they say, right, if we had a line going up there and another line going up there of this shape, and then they've got another line going up there to show you that it's the bottom of the shape. Let's try and get that angle about the same. And they've said to you, this angle over here is 24 degrees. So they've said, work out, the first thing they've said, and this is question 8, by the way, is they've said, work out the interior angle. So if that's all we've got of that shape. We don't have the whole shape. We don't know how many sides it has. We know nothing. The only thing we know is that this is 24 degrees. But I also know this is a straight line, isn't it? And what do angles on a straight line add up to?
180.
So to find this angle, I can just say, because that is the interior angle, I can just say Let me just put your angle, interior angle, so you know what we're looking at. I can say 180 degrees minus 24. And that equals how much?
Hold a second. Okay. 156.
Just that as you just get cleverer and cleverer. Right, that's the first little bit on that one. So they said, okay, work out the interior angle. Now, oh no, this is actually part of this one. Now, okay, I've just made up a different thing. Don't worry, I've mixed up question 7 and question 8. It doesn't matter. How many sides does this have?
It has.
If I looked at the whole shape, how many sides? If I could see the whole shape, how many sides would the shape have?
What shape is this again?
That's what we've got to work out based on what they've given us. And the only thing they've given us is this 24 degrees.
Oh, okay. 1, 2.
So think about what I just told you here. The exterior angles of a polygon sum to 360, right?
I think it's a nonagon.
You think it's a nonagon?
I'm just guessing.
I think you're wrongagon.
Okay.
Take this information. This information here. The exterior angles, all the exterior angles would sum to 360 degrees, right?
Okay, hold on.
So knowing that, what do I do with that 24?
Times it.
Well, I could times it, because that's what we had to do earlier. So we say 24 times the number of sides
That we don't know yet.
that we don't know equals 360, right?
Okay, no, then I go, okay, 360. That's like 24.
Yes, there you go. Now you're cooking on gas.
15.
Is it 15?
Yeah.
Are you sure?
There's no way there's no way this thing has 15 times.
It is 15. Oh, it is 15. Okay. I was trying to do it in my head and I was getting a different answer. I think my head's tired. All right. It's 15 sides. Yes, it has 15 sides. That's right.
I was not expecting that.
It had to be more than a nonagon, because a nonagon's exterior angles is 36. And the more sides you add, the smaller the exterior angle is going to get, because the bigger the interior angle gets. So it had to be more than a decagon.
That was less than a decagon, so I assumed it to be more. No, that doesn't make sense. Anyway.
Okay. I like number 12. I'm going to try draw number 12. Let's see if I can do
This
it.
diagram shows part of the identical regular polygons joined together around an equilateral triangle. The tongue twister. Work out the number of sides each regular polygon. Show how to get them.
So each polygon is coming together and they're meeting so that they meet where they form a triangle between the sides, right? And they've said about the triangle, it is equilateral. In other words, all three sides are the same. What do you know about the angles of a triangle?
Oh, I know the whole triangle equals 180.
Yes, angles of a triangle equals 180 degrees, okay. So if it's an equilateral triangle, then all three angles are the same size, aren't they?
Yes.
So how big will those angles be?
180?
No, all three added together must be
Oh,
180.
all three.
Yes.
180. Hold on, let me do this in my head. Okay, 1. $540. Wait,
What? No! Oh, Sarah!
Okay, wait. Times 3. I was right!
Why are you timesing it by 3?
Because you said 3.
Yes, there's 3 angles in a triangle. They all add up to 180 degrees. How much is each angle?
Are you saying divide by 3?
Ah, yes.
I thought you said times. I thought you wanted to know because of the
I didn't say times or divide. I asked you what to do. You're the one supposed to be helping me here. I'm supposed to be getting information from you.
Divided by 3. 60.
60 degrees. Good. Now, here comes the problem. These are not nice exterior angles, right? What I do have though is I have angles around a point here. Oh, what? Oh dear. Why did I do that? I don't want lines, I want pens. I have angles around a point, right? And I know that those angles around a point, if I take that now and I just enlarge it a little bit, then now I can do lines. I know that I have the following. I have one angle here that is 60 degrees. You with me?
Yes.
I have 2 angles here that will obviously, because they said these are regular shapes, so they'll obviously be the same size. I'll just call them X for now. What do the angles around a point add up to?
36.
Good. So 60 plus X has to equal 360, right?
Yeah. So it's 150, 150.
Good. So each one of these is 150. Good. Because I take the 60 across and subtract it, and then I've got 2x equals 300, so it must be 150 each. So each of these angles is 150 degrees. All right.
Whoop-de-doodle.
Sorry? You whoop-de-doodle. Okay, good. Whoop-de-doodle, yes. Whoop-de-doodle. Now, what they're actually wanting to know is this A, B, C, show that. Hold on. The number of sides. Yes, I thought so. Number of sides. Let me just quickly write the number here so that I remember which number to go back and look at. It's number 12. So they want the number of sides. So now what I know is I know the interior angle is 150. All right. I don't know. I can use the n minus 2 equals, times 180. I could use this one. Times 180 equals the total, but I don't know what the total is, so it's not going to really help me. So what I'm going to do is I'm going to go back to the exterior angles, because I know the exterior angles is going to give me a much easier way of solving this. So now I'm going to focus only on one corner of my shape. Now they've said that this angle is 150. Well, they didn't say it. We calculated it because we're very clever. So we know that's 150 degrees, right? If I then extended this line to make an external angle there. So now I make a straight line. It wasn't a straight line before because this was meeting at a weird triangle place.
Are we making a shape or something?
I'm taking one of the interior angles. I'm taking one of the interior angles on one corner of this shape that I don't know how many sides it has. So this is the shape is here. And I'm just focusing on one corner. But I'm going to extend one of the sides longer.
Oh, we're figuring out a shape of the shape. Okay.
We're figuring out the shape, yes. What will this angle here be? If that's 150 and this is a straight line,
100. 30.
Good. So that's a 30-degree angle, right? Now, what do the exterior angles, because now this is my interior angle. That's the interior angle. The 30 we've just worked out, that's the exterior angle. But we have a rule about exterior angles. What do they add up to?
360.
360. So, the number of sides, I'm just going to say n, times 30, because it's regular, so they're all going to be the same size, should equal 360. And that'll give me my number of sides. Happy with that?
Yes.
So what must n be?
N will be 60. No.
No.
Don't listen to me. Don't listen to me.
I'm not going to listen to you.
N will be 30, 12. Whoa.
Done. 12 sides.
Yay! Woo.
And that's about as hard as they get, Sarah. They don't get much harder than that.
Okay. That's good. And I understood most of you about the process.
Sorry?
I understood mostly throughout the process.
Good. And then after that, once you've done with that, because that's interior and exterior angles of polygons, you've only got 5.4 and then this chapter's done. Oh no, it's not. You've got 5.5. You've got Pythagoras. I forgot about Pythagoras. You remember Pythagoras though, don't you?
No.
Sarah, I taught you this. How can you forget stuff I taught you? How's that supposed to make me feel? I tell you how it makes me feel. It makes me feel hurt. You hurt my feelings. Right.
I'm trying to remember.
Pythagoras works only with right angle triangles. You've got a hippopotamus.
You did not teach me this.
Oh yes, I did.
You did not. Okay, wait. Let me see further into it.
We'll give a side A and we'll give a side B. And Pythagoras' theorem, and it's named after, it has to be written with a capital P, by the way, because it's named after a Greek chappie called Pythagoras. That's a cool name, isn't it, Pythagoras?
Sounds like a snake's name.
No, it's a Greek chappie, it's a Greek mathematician's name. If you have boys, if you get married one day...
It sounds like the name of a type of snake.
A type of a snake. I was in the garden yesterday, I saw a snake. What type? A Pythagoras.
Pythagoras.
Oh, because like a python.
Yeah.
Okay. I'm just about to prove you wrong though, because I'm looking at your year 8 book. Constructions, triangle.
But I also wasn't there at the beginning of the term.
You know what? Damn it, you're right. It's not in year 8.
Yeah, right.
You're lucky then. Okay, but anyway, if you get married one day and you have sons, call one of them Pythagoras. That's a cool name.
Okay.
All right.
Okay.
You can see the hypotenuse is the longest side, right? The longest side is always opposite the biggest angle. If that's 90 degrees, the two other angles have to be less than 90 because 90 is half of 180. So you can't have one angle that's half of 180 and the other two are bigger than that, because then your angles would not have to add up to 180, right?
Yes.
So this is what it says. I'm going to use a h for Pythagoras. Don't get scared. I'm just going to say h squared equals a squared plus b squared. That is the theorem of Pythagoras. So if you have a right angle triangle and it must be a 90 degrees, it has to be a 90 degree angle triangle. This theorem doesn't work for triangles that are not 90 degrees. Then your a squared minus b squared would be equal to the square of the hypotenuse.
Okay.
So for example, if this side was, let's think of something that'll add up quite nicely. I'm just going to go 25. Yes, it'll work. If this was 3 centimeters and this was 4 centimeters, and they said to you, find the hypotenuse, then you say the hypotenuse squared equals 3 squared plus 4 squared. Right. Squaring the two short sides. 3 squared is 9. Plus
25.
4 squared is 16. So the hypotenuse squared equals 25. Good. So if that's the hypotenuse squared, what is the hypotenuse?
What squared equals 25?
Yes, what squared equals 25?
Then I take 20, wait, that weird little thingy majabba.
Yes. Yeah, do that weird little thingy majabba like that thingy majabba.
5.
Good, it's 5. Because 5 times 5 is 25. Okay. Yay! What if they ask you for a short side though, Sarah? What if they give you a triangle and they say, here's your right angle triangle?
Yes.
Let me just see. I'm just trying to find ones that would give you. Let me just see. Let's go. Who cares? We're going to get decimals. I don't care. All right. Let's say that this side here is. I'm just going to make something up. We're going to get a decimal. I really don't care. That's 50 degrees. There's your right angled triangle, or 50 centimeters, not degrees. And maybe this side here is 40 centimeters.
Yes.
We're now looking for a shorter side, aren't we? So now I'm looking for side A. So I can't add these. I can't square and add because then it'll give me a side longer than 50, and I can't get a side longer than 50. That would be crazy because the 50 has to be the longer side. So now what I do is I say that A squared equals 50 squared, and I bring the B across and minus it, minus 40 squared. Okay, so on your calculator, what is 50 squared minus 40 squared?
900.
900. You know what? I think I've actually, by complete mistake, managed to get this to actually be a perfect square. Because now we need to square root. We need to do the square root thingy, remember? So we're going to square root the A squared. And we're going to square root the 900. Do we get a whole number? Aha. So then A equals 30.
You did it perfectly.
Isn't that cool, huh?
Yes.
All right.
Woo!
Centimeters, because it's a length. And that, Sarah, in a nutshell, is Pythagoras.
Okay.
They are going to try and do some tricky stuff with you, where they do different things, where they're going to now say, okay, well, what if you got a wall, so you got a wall over there, and you got a ladder leaning up against your wall, so you got a ladder up against the wall, and you've put your ladder a certain distance from said wall, and they say to you, okay, now what you know is your ladder, maybe your ladder is a 10-meter ladder. That's a really long ladder, by the way. Sarah, I don't want you climbing up 10-meter ladder. See, that's dangerous. And maybe you put your ladder 6 meters away from the wall. How high is the wall? So they want the height of the wall. Well, this is just Pythagoras. There's your 90-degree angle triangle. So you're just going to say that your height squared. We always start with everything squared, see? And the last step in Pythagoras is always to square root. It's going to be 100 squared minus 6 squared. Okay, back on your calculator. What's 10 squared minus 6 squared?
64.
Geez, I think, you know what? I think I've done it again. I think I've actually done it again. What's the square root of 64?
8.
Just as I'm getting good at this.
Yes,
Hey?
you are. It's automatic by now.
Must be. I'm tuned in. So don't let them scare you. And they'll do things also, Sarah, like they'll say to you, you've got to go and swim across some river. So there's your river, right?
Yes.
And it's a river, so the water's got to be in the river, so we're going to make the water blue. So you're in your river, you're swimming in your river, la 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 la, and there's a current pushing you down the river. Okay, so you were wanting to swim straight across the river, that's where you wanted to do, and the river was 5 meters. But when you got in the river, the current pushed you down, so that you got out the river 8 meters down from where you started. How far did you actually swim?
Okay.
So, what would you do?
Wait, no. 8 squared minus 5 squared.
Hold on, why are you minusing?
Oh, plus.
Because we're looking for the longer side. Remember, this is your hypotenuse here. Because there's your 90 degrees.
So is it, what is it? 5 squared?
Yes, so 5 squared plus 8 squared. So you're looking for question mark squared equals 5 squared plus 8 squared, right? Which is basically 25 plus 64.
It does not give me anything, it just says 89, 89.
Does it give you the answer as the square root of 89?
Oh, there you go, it gives me 9.43398.
There you go. So you actually swam, instead of the 5 meters, you actually swam 9 point, we'll just round it off to 43 meters.
Okay.
So they're going to give you weird questions like this, and you're going to look at this and go, but hold on a minute, that's not a triangle. Yes, it is. Once you start drawing in all the lines, then you can see there's your 90-degree angle there, that's your 90. There's your river going across, and there's your triangle.
Okay.
So they're going to give you questions where you don't see the triangle straight away, but if you think about it a little bit, you'll see that you can make a triangle. It will be a right-angled triangle. They'll ask you questions like, if you come to a soccer field and you want to walk from one point to the other, how much shorter would it be just to walk across the hypotenuse rather than going along that way and then along that way, if you just cut straight across a field? So then you've got to take your a squared plus your b squared, see what it gives you, take your hypotenuse squared, work out the sum of a plus b, subtract the hypotenuse, and get your distance. So they're going to give you all sorts of questions where they bring Pythagoras in, but you won't immediately identify it as a Pythagoras question. But once you start drawing your lines in, you'll start seeing, okay, now I can see the right angle triangle now. I can do my Pythagoras stuff and I'll be fine.
Yeah.
Good.
Okay.
In between the Pythagoras and the others is your constructions, but you just need to go through that and look and see. The instructions in the book is quite clear on how to do your constructions. They're going to do construction of a diameter, they're going to do construction of a square inside a circle, of a line perpendicular bisector to a line, of an angle bisector, and of a 60-degree triangle or an equilateral triangle. So those are things they're going to teach you how to construct. But the book does explain it quite nicely. So if you just follow the instructions in the book, it'll make sense, hopefully.
Okay.
Good. And I shall see you next week.
Yeah.
Good. Have an awesome weekend.
I will, you too.
All right. Cheers, Sarah.